With a warm greetings, I extend my warmest welcome to the talk show Education 4.0 for Safe, Sustainable Societies.
Good evening, everyone, and welcome to the talk show organized by Samurja Educational Society on the theme Education 4.0 for Safe, Sustainable Societies. We appreciate and applaud everyone, our panelists and participants, for the zeal to share and passion to learn with Samurja. Samurja, the sum of creative energy. Here is a small video what Samurja does. Over to Monica, please.
Samurja Educational Society, established in the year 1991, has completed its gratifying journey of 3 decades. The society was conceptualized with the objective of educating children and preparing them to be morally upright and vocationally independent. Ever since its inception, the society has continued to take tiny steps forward, redesigning the educational fabric in all possible ways through various educational activities, besides conducting social outreach programs like the Girl Next Door and the Charity War. Samurja is constantly striving to bring together some of the most ignited minds in the field of education to introduce change in the educational fabric of the nation by providing educational vision, empowering educators, inspiring learners, and elevating various organizations through training sessions, panel discussions, talk shows, conferences, and symposiums. The society has also conceptualized and published periodicals and magazines for students and teachers. Samurja continues to explore new domains, trends, and landscapes to enrich the educators across the country by equipping them to resolve the academic challenges in their classroom to make teaching and learning more joyous and engaging. It also helps educators realize their vision and collaborate with national and international educators to have sustainable societies and a happy nation, thus redefining the paradigms of Indian education. Jai Hind, Namaskar.
Just 2 days back, on this Teachers' Day, all of us received loads of wishes from our students, alumni, fellow educators, juniors, senior teachers, our mentors, and even from our family members. Everyone's WhatsApp was loaded with the messages. There was one message which was circulated the most. It was different for many reasons. It was a handwritten message with a ballpoint on a piece of paper instead of typed text. A handmade drawing was also supporting the message. Its photograph was clicked and posted. The second point was the message for appreciating a special teacher who has really made a lot of difference and taught us great lessons of our lives, especially from the past 1.5 years. This teacher also worked as a catalyst in actions and reactions of the policymakers, various organizations, administrators, hence resulted in the launch of NEP 2020 and its supersede processes of implementation. I trust all of you know this teacher. Yes, I'm referring to COVID-19. CBSE has also shared a lot of initiatives like art integration, sports integration, competency-based learning, case-based learnings, changed pattern of assessment from annual assessment. It has been changed into half-yearly and final assessment, besides change in the format of question paper, addition of MCQs and other objective questions. On one side, Diksha and Nishtha, holistic development programs from the Government of India, are continuously trying to train the teachers on content enrichment, pedagogy, and assessment. On the other hand, Nipun Bharat, National Initiative for Proficiency in Reading, Understanding and Numeracy, is providing support to teachers and students for foundational literacy and numeracy. Fit India Quiz, Aryabhatta Ganit Challenge, Read India Celebration, ATL Space Challenge are the CBSE competitive assessments of learning in our schools. Today, different stakeholders in education are struggling to address different challenges. Shift from classrooms to computer screens, format of instructions, attendance, assessment, the role of technology and human interaction, besides plugging in the learning gaps. We feel pride in sharing that the vision of our mentors, Dr. Ashok Pandey and Dr. Rajesh Hasija, is to update, align, and upskill the fellow educators by bringing the finest mind on this platform of Samurja. Samurja has initiated the subject-specific series Experion, how to balance this equation of learning, teaching, assessing in a subject, how to catalyze the processes, how to polymerize learner, teacher, administrator, and a parent in us. Means experiencing chemistry. And that's the topic for today, Experion Chemistry, Concept, Pedagogy, and Assessment. To deliberate on this topic, we have with us a dynamic school leader who has always been a keen learner, explorer, highly modest, awfully beautiful, charming Miss Geeta Gangwani, Principal, Bal Bharati Public School, Rohini. Geeta ma'am, we welcome you.
Thank you, ma'am. Thank you. Thank you to everyone. Thank you, Samurja. Thank you, Mukta ma'am, Ashok sir, Pandey sir, and thanks to all the participants.
I request Monica ma'am to please welcome Geeta ma'am and introduce her with a musical note. Thank you, Monica. We also have with us our mentor, Dr. Rajesh Hasija, Director in the Vista Group of Schools. Sir ensures that irrespective, whatever is the commitment, he's always there to bless us. A leader par excellence who actually prepares leader. Welcome, Dr. Hasija.
Thank you. Good evening to all. And thank you, Mukta ma'am, for carrying on such series to enlighten people who are in the field of education.
It's all your vision, sir. Thank you so much. Somehow, Dr. Pandey could not join us. We welcome Dr. Ashok Pandey, Director, Elcon Group of Schools, and Professor Harish Chaudhary from IIT Delhi, who is also mentoring us continuously, and they are big support of Samurja. Without further delay, I'll request Geeta ma'am to please share with us the latest changes in the concepts, the assessment, and the other pedagogical structures out of your experience aligned with CBSE moderations. Over to you, Geeta ma'am.
Thank you, Mukta ma'am. And first of all, Heartfelt gratitude to the technical team under your supervision, ma'am, for the hearty and musical welcome. Thank you so very much. Just give me a moment to share my screen. And while I share my screen, I want to say this, that I started my journey as a teacher in Bal Bharati Public School, Gangaram Hospital, Marg, and that was year 1988. And in the year 1988 onwards, when I started my journey, in the initial years, I would say, I don't mind saying this, my teaching aimed at above average children. And I used to do IIT kind of numericals and expected the same from the students in my class, as if everybody was a 90% and above holder. And though I gave my best to the children, obviously, because you always have a heterogeneous group of children with different abilities and, a mix and match of above average, below average children with different capabilities and interests, it did not give me rewards. It was very early in my journey as a teacher that I realized that I was doing something wrong. There has to be a change in my teaching style, and also my expectations from students, which were too high, have to be brought down so that I as a teacher don't get frustrated. And then I started my experimentation with classroom pedagogies, tried a couple of things. Then there was a time when I did action research, and the main reason why I did action research was because I wanted to know what's wrong in my teaching, in spite of my giving the best. I could see that bored expression on the faces of my children. So chemistry class used to look very, very monotonous with children not at all willing to be engaged. And then I would be sharing during the course of my presentation a bit of that also, and that in fact is the starting point of my presentation. And what NEP is now talking about is an extension of what has been a part and parcel of my journey, and the entire experimentation of 32 years, I would say, put together. And now I see it all the more structured in the form of NEP and what CBSE is also talking about. So let me start with my presentation. Before the presentation, I would request the technical team to please share a poll. So let me start with the poll. The day is experimenting with chemistry, the concepts, pedagogy, and assessments as aligned with NEP 2020 and as per CBSE. So my first question to the August gathering of teachers is that NEP 2020 is aligned with the UN Sustainable Goals adopted by India in 2015. So which is the goal number to which NEP 2020 is aligned, and by which year do we need to achieve this goal? So we can have your answers here now. A lot is being talked about SDG goals. We have 17 SDG goals. So to which goal is NEP 2020 aligned, and by which year are we supposed to achieve this goal? Can we have, Mukta ma'am, the results of the poll?
Yeah, results are there, but although I know what you are expecting, here the gap is very, very minimal. I mean, you can't, isn't a steep.
Doesn't matter. Dear participants, the correct answer is SDG goal number 4, and we need to achieve it by 2030. So option 4 was the correct answer to this. I think there's a very, very important point for us to broaden our vision, because SDGs is something that I think almost everybody is trying to implement in the curriculum. We are weaving SDGs in our curriculum in our schools in every subject. And therefore, it's important that we know that the NEP is also aligned to SDG goal number 4. So moving ahead, what does SDG goal number 4 say? SDG goal number 4 for sustainable development seeks to ensure inclusive and equitable equality education and promote lifelong learning opportunities for all by 2030. NEP aims at building a global robust system rooted in Indian ethos, thereby transforming India into a global knowledge superpower. The purpose of education is to develop good human beings capable of rational thought and action, possessing resilience, values, sound ethical moorings, courage, empathy, compassion, creative imagination, and scientific temper. I deliberately started in the direction so that scientific temper comes as the last, because in spite of the fact that we are chemistry teachers or science teachers, and even though we feel that building scientific temper is probably our only aim while we teach students, the answer is no. We have to build, while teaching chemistry or while teaching science, while building scientific temper, all the other core values which are required for a good human being to have sustainable and peaceful societies at large. NEP talks about recognizing, identifying, and fostering unique capabilities of each child and developing not only the cognitive areas, but also the social, ethical, and emotional areas. And again, I would like to stress that while we are teaching chemistry, let us not only focus on the cognitive aspect. That is what NEP talks about. While we are teaching any particular topic, social, ethical, and emotional capabilities of the children have to be developed through the content. By the way, different ways in which the content is delivered, that is the innovation that we are looking at. So basically, NEP 2020 talks about curriculum reconstruction, pedagogical innovation, and assessment reforms. So when you talk about curriculum reconstruction, I would not spend much time here, though our topic includes content, especially with reference to chemistry. I think we all will agree that there has not been much of a change in the content to be covered in chemistry, whether at the secondary level or senior secondary level, or even at the middle level over the years. And even the rationalized syllabus that the CBSE gave us for the higher classes, a few portions which are based on rote memory-based learning have been deleted, but most of it is retained. Also, we know that NEP talks about introduction of vocational courses, then AI, coding, contemporary courses. We are all waiting for the National Curriculum Framework for School Education, NCF 2021, which will be coming to us anytime from the NCERT. So based on that, the content may vary depending upon what is offered to us in the NCF 2021, it was expected to be delivered by March 21, but I think even the first draft has got delayed because of some reasons. So let us focus more on what we can do while we wait for the curriculum to be coming to us from NCERT. I think without any delay, most of the schools, in fact, all the schools, leaders, educators, teachers have already started with pedagogical innovations in sync with NEP 2020. I chose this particular picture because I really felt that at one point of time, my class also looked like this. Look at the expressions on the children, on the faces of the children. They seem to be so bored. Probably somebody like Mrs. Geeta Gangwani in the year 2000 was giving a lecture which they did not feel interested or engaged at all. So these are our traditional classrooms, and we need to convert our traditional classrooms to engaging classrooms. So gone are the time where a principal goes around the corridor and sees silence in all classrooms and believes that everything is perfect. No, if there's perfect silence in the class, something is seriously wrong. Because if your class is engaging, there would be students' voice. And unless you have that engagement in the class, nothing concrete can ever happen in terms of teaching learning process. So this is a clip from my action research, which I submitted to British Council and was awarded for that. So in this action research, I had started by putting this question in a survey form to my students as to out of the 5 subjects in grade 11 and 12, So this was given to grade 11. Out of the 5 subjects that are being taught to you, where do you place chemistry in terms of difficulty level as compared to physics, bio, maths, or English, or whatever your remaining subjects are? And it was actually surprising to see that only 3% students found chemistry easy, 13% found chemistry average. But look at it, 31% students found it very difficult, and 33% found it extremely difficult. That means 64% students, for them, chemistry was difficult or extremely difficult. So then I went on to explore what are the reasons. So I got it from the students itself, and gradually it was conveyed to me that I found chemistry boring. They find it monotonous. I mean, I will use the word found because it was past. So they found it monotonous. They found that the subject was based on rote-based learning, memory-based, total ratification. Exam se pehle yaad karo, or exam mein just vomit it out on the answer sheet. And they felt that there was no real-world connect. And it was difficult to visualize, because we talk a lot about structures, bond angles, bond strengths, bond spatial arrangement in 3D. So there's lack of visualization. They're not able to visualize. When they put it on paper in 2D, the 3D impact is not there. So visualization becomes a problem. And then they're scared to handle chemistry in the lab also, because sometimes, of course, there's a lot of heat which is given out, temperature goes up, so things like that. So I actually thought that what can the teacher do? And this is what NEP also talks about. So these are pointers that I've taken from the NEP document. NEP says that the teacher has to make the classroom learner-centric. So it should be student-driven. It should be discovery-oriented, inquiry-driven, integrated, holistic in nature. There should be opportunities for experiential learning, flexibility, discussion-based. Last but not the least, the classroom has to be joyful. And the onus of learning has to be on the child. That is a very, very important point. The children must learn to take onus of their own learning, and the learning has to be self-directed, peer learning, collaborative and cooperative learning needs to be encouraged. So while we talk about pedagogical innovations, pedagogy, where the teacher is on the stage, she's in the center. The NEP recommends that we move from pedagogy to andragogy, where the teacher acts as a facilitator or a guide by the side of the students. And more so, moving forward, we should be going to heterogogy, where the learning is self-directed and is based on research and reflection of the learner. Coming to pedagogical innovations, which are being talked about in NEP 2020 with a lot of emphasis in Indian and local context. So the pedagogical innovations are project-based learning, integrated learning, collaborative learning, multidisciplinary projects, quizzes and role plays, art integration, sports integration, again with thrust on indigenous sports, storytelling, puppetry, toy pedagogy, and theater in education. So how do we take it forward in the subject chemistry? So till now, what I spoke was a bit generic as to what NEP talks about in terms of pedagogical innovation, and this can be tried in every subject. So one really wonders, how do we go about it in sciences? It's easier to integrate all this probably in languages, in social sciences, but when it comes to sciences, probably there's a mindset, but then it's so very easy and it's so beautiful, and you will see the engagement of children going multifolds when you try all these pedagogical innovations. Art integration. So this is one example. You would see that in my session, I have taken up examples which I have tried and have been successful. So there is no end to innovation. In every session, I say this, and pardon me for saying this, that every session, has about 2 to 3 take-back points. So you take clues from best practices which are being shared with you, and then it is now for the teacher for the participant to go back, explore more, research, experiment, and do what you really feel like doing, depending upon your own strength and depending upon the capability of your students and availability of time and other constraints. So this is something which I try year after year. So every year we have competitions within the class, within 2 sections also, wherein the structures that they study in chemistry, they have to depict those in form of a rangoli, or it could be any other art form. The emphasis here is not on the choice of colors or the material that you take. The emphasis and the assessment again would be on the correct orbitals taken, bond angles, bond lengths which are depicted, and the spatial arrangement which should be true to the correct picture of the compound under investigation. So this is one example where students are making benzene. This is a beautiful example of creativity and artwork in the formation of compound magnesium oxide. And this, I must say, is also one of the artworks which featured in the NPSC calendar. So here again, it is not the floral artwork of the child that we would appreciate. Of course, we would appreciate the aesthetics. But more than that, one really needs to look into is the correctness of the orbitals and the placement of electrons in the orbit. So there has to be 2 electrons in the inner orbit, 8 electrons in the outer orbit, and then 2 more electrons in the valence shell. And these are the valence shell electrons which will be transferred to oxygen when magnesium oxide is formed. There's another way in which we integrate art. Every year in my school, we celebrate the National Mold Day, which is on 23rd of October. We also float many inter-school competitions on this day. And this is one such event, that is t-shirt painting, where whatever the child wants to portray on the t-shirt must reflect that 1 mole is 6.022 10 to the power 23 particles. So this is another example of art, even though this is art with the help of ICT. So here, basically, children have used cartoons. So as you can see, one cartoon or one piece of artwork is nitrogen, who says that I'm very poor. And the nitrogen is very sad because it has got 3 less electrons. And on the other hand, you have aluminium, who's very rich. In spite of being rich, aluminium is sad because aluminium has 3 extra electrons. So in 1982, the compound ALN, aluminium nitride, was discovered. So in 1982, the aluminium and the nitrogen got married. So you can give these kind of works to the children. So there are 2 ways of doing it. Either one way is you teach like this. You teach one example like this, and then you see your children will come up with so many more creative such works, where the understanding of chemistry behind a particular concept is depicted by the students in form of the artwork, but the concept is what we have to focus while we are integrating art. So that is a point I'm reiterating again and again. As teachers, we should not get lost or misled in the beauty of the artwork. More than the beauty of the artwork, it is the correct conceptual clarity and the data relevant to chemistry that is to be reflected correctly by the student. So this is another example of art integration with performing arts that we have tried in our school very, very successfully. Probably you'll be able to see that on the left-hand side, the picture, there's something written over the caps, which is SN2 and SN1. So this was a face-to-face between SN1 and SN2. SN1 is nucleophilic substitution reaction unimolecular, and SN2 is nucleophilic substitution bimolecular. So while the SN1 and SN2 are having a dialogue or a role play or a script is being written, there are other characters also in this drama. The emphasis is not only on the theater part or on the dress or the voice modulation. The emphasis is that while the dialogue or the script is being executed, all chemical, physical properties of the phenomena are very clearly elicited and understood by the audience. Similarly, on the right-hand side, you can see that there is this event going on, which is where you have resonance as a political party leader So maybe he's another, let me not take the names of any politicians, but let me just say that the resonance is a political party leader, and there is a voting request for vote for resonance that is going on. Now, no matter what kind of drama is being integrated into it, the emphasis would be on what is resonance, how does resonance help in establishing structures of different compounds, and what kind of electronic rearrangements occur. So even while you are voting, you are asking for votes for resonance, you are highlighting the properties of resonance, which are pure chemistry concepts, and assessment and awarding of marks or prizes have to be on the correct chemistry involved and shared by the students. So this is something which I have been trying for years and years, and it really works wonder. And here I would also say one thing, that our science classes are normally a bit monotonous because maybe there is too much of teacher talk. But one more thing which is absent from a chemistry class vis-a-vis a English class is lack of humor. And adding humor is so very easy, even in a chemistry class. And it happens very easily if you connect various terms, phenomena, concepts in chemistry with very, very commonly available or observed real-life situations. So, for example, electronegativity, polarity of bonds or types of bonds can be correlated with sharing of lunch between two students in the recess. I will take it up again because there's a picture for this that I've added in my subsequent slides. Let us come to spatial clouding. So the moment you tell children spatial clouding, the word is so heavy. They keep on thinking, "Arey, what is the spatial clouding?" The moment you say, "Arey bhai, bheed bhadakka," so that is what you have when you have a 20 minutes recess and it's the month of June and July. You have returned from the playground. आपको बहुत प्यास लगी है और फ्लोर पे आप जिस फ्लोर पे आपकी क्लास है वहाँ एक ही वाटर कूलर है ऑब्वियसली, तो उस वाटर कूलर के पास इतनी भीड़ है कि आपका पहुंचना टैप की तरफ बहुत मुश्किल है. So that is spatial crowding. So simple to understand, and your children would never ever forget it. Another very, very easy example of activation energy in presence of a catalyst can be given by the purchase of a household commodity under discount. Simple, you can give any example. It's Diwali time, you want to buy a TV, you want to change your TV, the TV is for, let us say, 45,000 और आपके पास कुल मिला के 40,000 रुपए. आप क्या करेंगे? So your 45,000, which is the cost of the purchase of the TV, is your threshold energy. You have 40,000, that is the energy of the reactant. You are short of 5,000. So that 5,000, beg, borrow, steal, कुछ भी करो, आपको 5,000 चाहिए. तो अगर वो 5,000 आपको हम supply कर देते हैं, you'll be able to buy. So this 5,000 rupees is your activation energy. But supposingly, there comes a discount offer of 5,000. So because you got the discount offer, now you're able to buy the TV. So that discount offer is your catalyst. So catalyst decreases the cost of purchase, or catalyst decreases the threshold energy required for the maxima to achieve. And therefore, in the presence of catalyst or in the presence of discount, you are able to go to the products or achieve or buy your TV. So these are very, very simple examples. And you see, I have tried it for years and years, and I've seen that the moment I introduce any such example, and there are n number of such examples, I've just taken 3. You will see such a broad smile on the faces of children, and they will be engaged to an extent that you will not stop laughing for another 5 to 7 minutes, and they'll give you so many other such relevant examples. And they will add on to the humor in the class, and your class becomes totally engaging. And the beauty is that they will not forget this concept ever in their life. So this breaks monotony and relates the topic to the day-to-day situations. So a lot of creativity can be brought about in teaching of chemistry. So all this we have tried. And if E stands for any entity, that entity can be an atom, molecule, ion, process, or phenomena. You can have a letter writing from E to E. Why do we restrict letter writing to only English? You can write a letter in any subject. We have tried it in chemistry. Letter from Cl to Cl minus, letter from Na to Cl, letter from B block to P block. So anything, between any two entities, wherever you want to bring about a contrast between two entities, phenomena, processes, you can give it a shape of a letter, or you can have a dialogue between the two E's. You can have a face-to-face between two E's. You have heard about coffee with Karan. You can have coffee with E. You can have an autobiography of E. हम बहुत छोटे थे तो हम लिखते थे जुराब की आत्मकथा, और हमें कभी भी नहीं लगता कि साइंस में कौन सी आत्मकथा हो सकती है. But you can have an autobiography of any element, any compound, any process, any entity, whatever you feel like. Again, emphasis is to be on correct conceptual clarity by the child and not on the flowery language that the child uses. So on the right hand side, you will see a picture where, as you can see, one child is having phosphorus, chlorine, arsenic. So the child is representing P block. On the right hand side, the child is having scandium, titanium, vanadium. So she's representing D block. So it's a face-to-face between P block and D block, wherein the properties of the P block and D block, the similarities and differences have to be highlighted by the pair while they enact or personify the P block and the D block. And NCERT CBSE collaborations, you have on Diksha portal these graphic novels available. And I just looked into it. There was a graphic novel on class 9th chapter, Structure of Atom Valency. And when I looked into it, do you remember in some movies, we have one or two songs जहाँ पे कहते हैं बच्चे जो हैं वो चॉकलेट वाले पार्क में पहुंच जाते हैं, तो चॉकलेट की नदी है, चॉकलेट टॉफियां पेड़ पे लटकी हुई हैं. So that kind of imagination has always been existing over decades and over the century. But when it comes to chemistry, we don't think about it. So this particular graphic novel takes the child. I mean, you can go to the Diksha portal and you will be able to access the entire booklet which has come up on this, and there are many others. Graphic novels are available on many topics, many subjects. All are available at Diksha. It's a free resource. So in this, the child is sleeping and is dreaming about a park, and in that park, the child is to see all molecules, atoms, and compounds. So the top is water that the child that has come across in his dream, and the lowest one is neon, जो कि बेचारा अकेला है पर जगमगा रहा है क्योंकि neon अपनी light फेंकेगा सब तरफ. So you have art integration has no boundaries. You can do art integration by hand. Your children can do it. You can do it. You do it as a pedagogical innovation. You can use it as an assessment also. And you can do art with hands, or you can do art using ICT. So this is another example of how there is no end to creativity and imagination, even in chemistry. So you can ask your students to create a new superhero to be a part of a special force. And the force has been named as the Super Atomic Heroes League. And all the superheroes in this league, they receive their power from an element of the periodic table. So the students need to create a superhero, and a story has to be created with the superhero. Again, the emphasis is that they have to talk about the element and its properties, how it combines with other elements to make a compound, then talk about the compound, the characteristics of that compound. So superpower is the power of the element to make a particular compound and the uses of that particular compound, and how that compound can be used to solve our real world problems. In chemistry, everything is a solution for a real world problem. So keeping that in mind, this particular task was made for the students, which the students really enjoyed. And our favorite, the ICT-driven pedagogy. So with the open educational resources now being available, you can always enhance visualization. Students have difficulty in visualizing shapes, bond angles, mechanisms, Let us admit that. No matter how beautifully we draw everything, the students in 2D are not able to visualize the shapes, bond angles, and mechanisms. Especially I'll take one example where when we talk about the nucleophilic substitution reactions, in some cases there is inversion of configuration. Children are not able to visualize that inversion, and they simply memorize that there is an inversion in this particular mechanism. In the absence of that, their retention again becomes almost nil, and again we are back to monotonous rote learning based teaching, which we should avoid. So we can use video, stimulation, gamification, animations. I will take you through one example each. So these are examples of PhET stimulations. I've taken this simple example because I, even in my age, find it very, very interesting and very meaningful also. So these are PhET stimulations which you can use in sciences, and very elementary knowledge, but with this knowledge of how the atomic structure is built is the building block for chemistry. If children don't have the total conceptual clarity about structure of an atom, even up to grade 12 and in higher studies, they will have problems. So you can have children share things, have the children explore. So you take the proton in the nucleus. If I am a creative person, or I'm an open-minded person, I'll say, why should I take my proton to the nucleus? Let me have my electron in the orbit. Oh, if I try to put my electron in the orbit, it bounces back to the nucleus. And as soon as there is one proton in the nucleus, you automatically get the atom hydrogen. And because you've not added electron, there is a positive charge. Let me have an electron. Why can't I have the electron in the nucleus? Oh, if I put the electron in the nucleus, it bounces back to the orbit. So this clearly reinforces with the child that the proton has to go into the nucleus and the electron will go into the orbit. And the stimulation is so effective that if you put a second electron in the orbit, and let me put it near the first electron and see what happens. Oh God. The second electron has moved away from the first electron. That is because of spin repulsion. So electrons will occupy positions as away from each other as is possible. And if I want to put a neutron in the orbit, it comes back. So what I mean to say is that you have the aid of ICT now, and you can share these links and simulations with your children. Children can practice, enjoy doing it day in, day out, repeatedly. For example, you will not believe, but I enjoyed this, और मैंने इसको खुद 4-5 बार किया होगा कल when I was putting it in my presentation, because it's such a beautiful animation. If you have a compound with 3 atoms, so obviously there's one central atom and 2 surrounding atoms. Let me see what is the molecular geometry. It is linear. What is electron geometry? It is linear, because there is no lone pair. Both the pairs are bond pairs. Let me see what happens if I put a lone pair. If I put a lone pair, look at the shape. Molecular geometry has become bent and the electron geometry has become triangular planar. We keep on drawing it on the board and explaining it to the children, but the children don't understand because they're not able to visualize. Here comes the second lone pair and the shape is still bent and the molecule becomes tetrahedral. So this is again something we draw on the board, but the students are unable to visualize. Once they see or do these stimulations, it's so easy. Another lone pair, and the electron geometry is trigonal bipyramidal. Shape becomes linear because the 3 lone pairs are placed in such a way that the bond pairs are linear, and the octahedral shape, 4 lone pairs. Students are not able to understand how the shape still remains linear with 4 lone pairs. So the moment you have such stimulations, I'm sure your children would be able to visualize and retain things in a better way. You have beautiful animations which are available on YouTube. Of course, you have to spend hours and hours and hours together to select the most appropriate video for your children, video which has correct content and correct spatial orientations, if that is your motive. So we talked about SN2. SN2 reactions are reactions where you have an attacking nucleophile, and when the attacking nucleophile attacks, one nucleophile leaves, but in the process, the configuration becomes inverted. कॉन्फ़िगरेशन उल्टी हो जाती है. अरे एक ग्रुप, बच्चा हमेशा ये बोलता है एक ग्रुप आया और एक गया, तो ये कॉन्फ़िगरेशन क्यों चेंज हुई? He is not able to understand. So once the child watches this particular animation, I'm sure there would never be any problem. The inversion is so beautifully depicted, and there is a repeat show also. New bond being formed, transition state, old bond broken, and with the breaking of the old bond, the configuration becomes inverted. And this is the energy consideration. Look at the energy changes while the bonds are changing. Look at it again. When the leaving group leaves, the energy decreases. Energy is maximum when there's this transition state. Transition state, maximum energy, loss of leaving group, decrease in energy. I'll stop here because we are short of time. Then you have this Tinkercad where you can tell your children to practice making different shapes using balls, cylinders, and they'll be able to visualize the structure. The common mistake, especially in junior classes, is structure of methane, which they draw as square planar. So once they use Tinkercad software, they will understand that methane is not square planar, it is tetrahedral in shape. And this is my favorite, textual tinkering through doodles. A doodle is a rough sketch. You don't have to be an art student to really draw sketches, but your sketches, again, should be, through the sketches, you should be able to convey the concept that is being talked about. For example, this is one sketch drawn by a student, and all that the child wants to say is that more reactive is the metal, more will be the ease with which it will display another metal from its compound. We all know potassium is more reactive than sodium. So potassium can always replace sodium from sodium chloride. So here in this sketch, Cl is saying, I'm leaving you. U stands for sodium because Cl is talking to sodium. So I'm leaving you for potassium. So the concept here is single displacement reaction. More reactive metal displacing the less reactive metal. Okay, so this is one example which I talked about, electronegativity, polar and non-polar bonds. And this is what I normally talk to my children, and they laugh and laugh, and they always remember this concept after that particular class. That is, supposingly you are having a lunch break and you are two friends. So between the two friends, you are sharing a lunch. Supposingly there are 4 cakes, cupcakes, samosas, sandwiches, whatever it is. Now, if the plate is in the center and both the students take two pieces each, this would result in the formation of a non-polar bond. However, if one child is a bullying type, or if one child has a greater speed to eat, then probably out of the 4, he eats 3 and the other girl gets 1. So that is your polar bond, with the one eating 3 getting a negative charge and one eating less getting a positive charge. There could be one extreme case where the boy takes all the 4 and the plate is totally towards that particular boy. So highly polar, leading to high ionization charges and dipoles being developed. So these are simple doodles. I will skip this and come to the next. Project-based learning. NEP 2020 has greatly recommended that students be involved into collaborative works in groups. They should work on real-world problems, and then they should research, complete the project, brainstorm, find out the solution. Teacher is all through the journey facilitating, giving inputs, giving feedback at every stage so that the children are able to complete, and in the end children come up with either a tangible outcome or a solution which is then shared with larger group for further feedback and improvisation. We have had in our school exhaustive trainings in PBL, and this is one example of PBL which our students did last year, and because it is in all sciences, so I'm sharing this. So the driving question for the students was, how can you make a cafe for the elderly people of the society to make them feel special and create a sense of empathy amongst the young generation for them? So different children in the class were divided into different groups. While one group worked on cafe layout, so maths and visual arts, the other worked on cafe menu, meal planning and biology, cafe crockery, chemistry, another group worked on. Our fourth group worked on the cafe lights and sound arrangements and maybe physics. How do you manage the waste that will come out from the cafe? So that is EVS focus. So one group worked on that, and one group worked on the rate list of the menu and how the accounts will be handled and what could be the possible profit or loss and students. And this all happened online. There was no problem. Students have their own breakout rooms. They create their own Google Meets in groups, and they've created such wonderful project. And they came up with solutions as to what kind of comfortable layout for the elderly, what kind of games the elderly will enjoy, what kind of music would elderly enjoy, what kind of menu would suit their age, and what should be the rates, what should be the interior be looking like. We should not have flashy lights and loud music, things like that. And it was a wonderful project-based learning activity done by the students. NEP talks a lot about the onus of teaching learning being on the learner. So metacognitive thinkers have to be developed by us. How do we develop metacognitive thinkers? What should be done in the teaching of science so that students become metacognitive thinkers? That means they think about their own thinking and learning process. I've taken some examples from this book, Making Thinking Visible. The book only gives you these strategies. It doesn't give you strategies of a particular subject. So I've taken the strategies and used them in my subject in the last session, and some of these worked very well. So I'll just pick up 2 or 3 which I tried, and you can have the availability of the book on Google also. You can go through it, or you can take clue from what I'm sharing with you. So one visual thinking activity that you can do with the children is see, think, wonder. So you show them whatever you want to show them, a picture, a demonstration, an activity, an experiment, but do not tell them what is the aim and what is the expected outcome. Normally in chemistry or in sciences, we have a habit of giving the aim. So the child already knows what is the aim or what is it that the child is going to come at or arrive at after the particular demonstration or activity. So don't do that. Just tell the child that this is what is there in front of your eyes. Now you write one thing that you see, write one thing that you think, write one thing that you still wonder, and voice it out. And then whatever the child has written as see, think, and wonder, from there the teacher takes the class forward. That also helps the teacher in knowing where the class is and what the class is thinking aloud about. So if a picture like this is given, the child may say that I see that there are sodium and chlorine atoms. And I think that the bigger green balls are chlorine, because the child may note that the anions are bigger and the cations are smaller. But the child may wonder that why each sodium is being surrounded by 4 chlorine, because children know NaCl as NaCl. So this is a very, very common myth in chemistry that NaCl is NaCl, 1 Na and 1 Cl. It's not that. We know in 3D, it is 6 Na and 6 Cl surrounding each other. But in the 2D picture, he would wonder why there are 4 Na and 4 Cl surrounding each Na. And he may also say that we always say that solids are non-compressible, there's no space. So why am I seeing so much of interparticle space? So see, think, wonder is one activity. Another very, very important activity, a very beautiful activity, which is a silent activity, is chalk talk. So in chalk talk, what you do is the teacher gives chart papers to the students in a physical class. In online class, you can tell them to go in breakout rooms. The teacher gives a question or a prompt, and the students, without talking to each other, write about what they feel about the question or the prompt. They can add on to the comments of the others. They can draw connections. They can put question marks. They can raise queries. They can appreciate each other's work. So this is one that I tried. So the prompt question was, are you eating an apple or a pool of electrons? And here, see what Kavyansh has written. He says that I disagree. An apple is made up of atoms that consist of electron, protons, and neutrons. So while we are eating, we are eating pool of ions. We are eating pool of subatomic particles, to which another child has written, we don't eat ions. So it's such a beautiful collaborative activity. Can be done offline, online, both ways. You must try using it. And the prompt question comes from the teacher. A very easy way of using visual thinking routines or developing metacognition is using this activity, which is claim support question. So you show this picture to the students. This is the common Rutherford's experiment, and tell the students to write one hypothesis, one claim, one thing that they're sure about, that this is my claim. Support their claim with the help of reasoning. And if you have any more questions, raise those questions. So one of the answers I got for this was, a child wrote the claim as, most of the space inside the atom is empty because I see most of the alpha particles passing through. So that is what he wrote in the support. But as a question, he said that if most of the space is empty in the atom, then where are the electrons? So based on that, the teacher can build up the further strategies. This is zoom in, a very easy activity. Show them parts of a picture and then keep zooming in. So show only the first part, then the second, and then the third. Let the children correlate and arrive at the final structure by correlating the first piece, zoomed in second piece, and the zoomed in third piece. And you can always use building as teaching aid, BALA. That is recommended by CBSE also, by NCERT also, that all the physical spaces in the school may be converted to learning aids or teaching aids. So this is the venue of my chemistry lab, where on the walls, these are the teaching tools that we have painted. So I'll talk about assessment reforms. CBSE talks about assessment which is holistic, which is based on competency testing. I would rather not talk about the changes in the format, because I think each one of us is very much well versed with the inclusion of MCQs, case-based studies, assertion, reason. So when I thought about assessment, I wanted to share something which is still not very common in schools, and probably would be a take-back point for you. So we all know that in NEP talks about regular, continuous, competency-based formative assessment, and the assessment should test higher order thinking. My request would be for a poll here, if the team could put in the poll.
Yeah, ma'am, it's launched.
So the NEP talks about assessment for, as, and of, learning. So what do you think assessment for, as, and of focuses on or refers to? Which of the practices are being referred as assessment for, as, and of? CBSE also talks about it. NEP also talks about it.
I think we are leading with the C point, metacognitive, formative, summative.
Assessment 4 is always remediation. It is formative. Correct answer is B. Assessment as is the assessment done by the child while the child is learning. So that is as. B is the correct answer. Assessment 4 is formative, off is summative, and assessment as learning is the learning assessment done by the child as the child moves further and assesses his or her own learning. And that is how metacognition is being talked about. After the poll, it takes 2 minutes to switch on to the next slide. Okay, so this is the change that NEP is talking about. NEP says that in the traditional model, the maximum weightage was for high stakes summative examination assessment of learning. But now they talk about the maximum focus should be on assessment as learning. Assessment as learning is that the child thinks about his own learning, refines and adjusts his own practices to have greater learning, while the assessment of learning comprises of a small percentage of the total assessment being followed. So assessment has to be of cognitive, affective, and psychomotor domains. Holistic assessment, we must have self-peer and teacher assessment. There should be project-based and quizzes and inquiry-based teaching learning. Therefore, assessment will also be of these activities, quizzes, role plays. You assess what you teach and you teach what you assess. So once you talked about pedagogical innovations, your assessment has to be reformed accordingly to assess your pedagogy. So this is just an additional slide. You all know what is multiple intelligences. When it comes to assessment, the only thing that I want to refer here to is that NEP also says each child is unique. Each child has unique capabilities. Give more choice and voice to the student. So while you are teaching, give greater variety to the student to assess that particular information or concept. And while you are assessing, again, give choice to the students to assess them in multiple ways. So, for example, if you are assessing your children on a topic like element compounds and mixtures, you can give them a choice. Either they can make a cartoon strip depicting dialogue between a compound and a mixture, or element or compound, or cation and anion, or they can make a song on periodic table, or they can do a crossword. They can also make a crossword, or they can do a loop card game, or they can make a model. Now, when it comes to crossword, you will see that I've given you a link here. You may kind of take a screenshot of this link. It's a very easy software where you can make crossword. When you go to this site and you move downwards, see, you are getting words and clues, right? So you write your word here and the clue here, and when you go down and submit, make puzzle, go to make puzzle, the puzzle will come to you automatically, right? Now, my point here is that we always, this is how it looks. So if I made a puzzle like this was a site I went to and I submit, then this is the puzzle which came to me ready-made. Now, my point is that please do not always give questions to your children to answer. Now is the time NEP says, tell your children to frame questions. So you introduce them to this site, tell them to make a crossword, rather than you only making the crossword and giving it to the children to solve. Try that. Students will be more engaged and you will get a variety of crosswords coming from them. Same is the case. This is called tarsia. Tarsia is a arrangement of triangles in such a way so that what is written on one edge of triangle is the answer or is related to what is written on the other edge of the triangle. For example, if you take the triangle D, there's written zinc. Opposite to zinc In triangle B, it is period 4, 30 electrons, right? So students, again, Tarsia is a free software. That is how it looks like. You can place your answer. Stage 1 would look like this. And once you submit, your Tarsia would look like this. Explore the site, make Tarsia, cut the puzzle and give it to the students to join. Or tell them to frame Tarsia. Let them make questions. That is how the children will be involved. These are loop cards. Supposedly you want to do an activity on aniline, so you can have a linguistic activity where aniline has been declared the winner of the benzene derivative family after knocking out chlorobenzene, nitrobenzene, benzaldehyde, benzoic acid, and acetophenone. So aniline is now being interviewed at the Republic channel by Mr. Arnab Goswami. Write the interview. So you're catering to linguistic intelligence. Or do the role play of the above talk show. You are catering to kinesthetics intelligence. Or make a concept map. Give them words to make concept map. You are catering to logical mathematical intelligence. This is my last point. I know I've exceeded 5 minutes. Mukta ma'am, pardon with me. I really want to do this. Choice boards. One choice board, tic-tac-toe. This is the work of my chemistry PGT, Miss Monica Arora. After I introduced the staff to choice boards. A choice board is an arrangement of 9 activities. And each one of these 9 activities on a particular topic can be made by the teacher in a thoughtful way so that each activity pertains to one particular type of multiple intelligence. And the students can be given a choice. They are supposed to do maybe any 3 activities, either as a row or as a column or as a diagonal. So depending upon the intelligences and the choice of the students, the children can do any 3 activities. You must have by now read the activities. So when it is spatial, you can use Tinkercad. When it is visual, you can draw the structures. When it is intrapersonal, you can make a brochure. When it is interpersonal, you can have a dialogue or a role play. When it is musical, you can compose something. So what NEP says in assessment is that while you are assessing your children, give them choice in the way they want to be assessed. And sometimes we find it very difficult how to assess, but there are so many other ways. You go to the Google, just type the word choice boards and you will get a variety of choice boards. But then you have to use your subject expertise and your conceptual knowledge to create a very, very sound choice board in which you are able to test the knowledge of the child while giving that freedom to the child. And of course, for assessments, which are assessment as learning and assessment for learning, you have a lot of ICT tools. I'm sure each one of you is using it. I'm not going to the details, just naming a few that are very, very common and are being used by each one of us day in, day out. Kahoot, Padlet, Quizzy, Quizlet, Exit Cards, EduPuzzle, and Mentimeter, of course. These are quick assessment tools. You can always keep a record of these tools. And the live worksheets, a very important tool. Use these tools for assessment. And of course, you have a change in assessment when it comes to the term ending assessments. It's become MCQ and all that. Alongside that, do continuous assessment, use ICT tools, use choice boards, use greater creative methods of assessing children so that children are loving to be assessed. And while they are presenting their work, you can always incorporate peer and self-learning. If you haven't yet started on peer and self-learning, I think that should be the next immediate target. Once you give assessment choice to the students, then the children are given opportunity to present their work. While they're presenting, you can have peer assessments and self-assessments, a bit time consuming. You may have it once in one term, or depending upon the availability of time, once in one session, but get started. So this is my request to each one of you. So in the end, I would just say that NEP, according to me, is not a policy, but a mission. And it is a responsibility of each one of us to take this mission forward and implement it in the true spirit. Science is like any other subject. Chemistry is like any other subject. There's a lot of scope for pedagogical innovation and experimentation. So I rest my case, Mukta ma'am, and if there are any questions, I'll be very much willing to answer. And one thing I would say, which I say in every session, dear participants, this is just a glimpse, if we stop talking about metacognition, we stop talking about choice boards, we start talking about ICT users, each one of it is an independent 1 hour, 2 hour session, right? So the idea was to apprise you of what all we have successfully tried and what all people are doing around. And in case there's something which you have not tried, that could be your take back point. Rest, the responsibility lies on your shoulders, which I'm sure are not fragile, but strong enough to take it forward. I speak this for my passion for chemistry. Thank you so much. Mukta ma'am, आप mute पे हो. You are on mute.
I didn't feel that the session, it has exceeded time, because, or it's a one-sided communication, because continuously I am reading the messages in the chat box. Thank you so much, Geeta ma'am, for inspiring so many teachers. Since the time is already exceeded, I'll request Kriti ma'am to please propose the vote of thanks without further delay.
If there is any question, ma'am, I'll be willing to answer. No problems.
Thank you, ma'am. Dr. APJ Abdul Kalam said, if you want to shine like a sun, first burn like a sun. Good evening, everyone. On behalf of Samurja Educational Society, I, Kriti Kapoor, would like to remark a proficient sense of gratefulness to Ms. Geeta Gangwani ma'am for sharing with us some of the finest skills. All the participants of this episode, including our team, all are inspired by your highly sparkling knowledge, ma'am, and your explanation about goal number 4 that we have to achieve by 2030. Secondly, teachers must encourage and follow collaborative learning, peer learning, experiential learning, and yes, of course, joyful and innovative learning. Third point, assessment should be regular, continuous, and formative. We can also make our classroom more attractive by using crossword puzzles or tarsia can be used instead of just giving questions and answers in the class. Kahoot, Padlet, Quizlet, these are some of the websites or the apps that one can use to make this magic in their class and can be used for taking up assessment also. I'm sure that all the participants have taken note and will be discussing within their organization also. I thank our leaders, Dr. Rajesh Sridhar sir, Dr. Harish Chaudhary sir, Dr. Ashok Pandey sir, for their leading supervision and inspiring us at every point. Thanks to the Vice President of Samurja Educational Society, Dr. Mukta Mishra ma'am, for her full-fledged support in every episode. A special thanks to Samurja team and Ms. Monica Khanduja ma'am for working round the clock for the success of every episode. Once again, thanks a lot to everyone. Namaskar.
And thank you to you as well. You also do a lot of work. Thank you.
Thank you to the entire team, those backstage, technical support, and dear compares, everyone. Thank you so much.
Thank you, ma'am. Thank you, Kriti ma'am. Thank you.